Hello guys and welcome to Battlefield 5 PC game running on 6K resolution native with the help of Apple Pro Display XDR monitor and two Titan RTX video cards and SLI through the NVLink bridge and Core i9 9th generation Intel Core i CPU 9900K emulated as i5 9600K at 5.3 GHz per core or 5300 MHz per core. Okay. Let me real quick go ahead and show you the preset. Today during this video I'm going to show you guys 4 different presets. I'm going to show you 6K resolution, of course, 6016 pixels by 3384 pixels. Don't worry about my hertz of my monitor, guys. The FPS is unlocked, so the display information system, the FPS performance will be the same no matter what kind of hertz 6K resolution screen that you are running. So pretty much you want to keep your eye at the FPS, not at my monitor hertz. Okay. Advanced. Okay, so I'm going to show you guys ultra preset. I'm going to show you high preset, I'm going to show you medium preset, and I'm going to show you low preset. So pretty much I'm going to underline all the presets, 6K resolution on two Titan RTXs in SLI, no matter what monitor brand you're running. Apple, Dell, Samsung, LG, Acer, it's still going to be the same performance on two Titan RTXs in SLI and Core i9 or Core i5 9th generation at 5.3 GHz per core or 5300 MHz per core. Okay guys, and let me real quick go back to the game, and also I would like to mention that future frame rendering is on, VSync is off to be able to show you the maximum possible average FPS, and it's under the DirectX 11. DirectX 12 is disabled because DirectX 12 doesn't support 2 video cards or multiple video cards. Hopefully guys this makes sense. Let me go ahead and real quick show you some on foot action. This video will be one take. I'm not going to edit this video. I'm coming in real time. English is not my first language, but I was PC gamer, PC hardware enthusiast, PC overclocker since 1998 when I made my first computer out of the parts. But I was PC gamer since 1992. Plus I'm a 3D artist, graphics designer, software developer, and system engineer. So I have a lot of guys experience and information to share with you guys from all kind of different multi-angle views. Hopefully guys this makes sense. So not only if you're a PC gamer that you're receiving great value over here by watching my videos, you're also receiving the great value if you're Apple fan, if you are a PC hardware enthusiast, if you're 3D artist, graphics designer, and etc. And even PC overclocker. So guys, as you can see, I got the SLI working under the Direct3D 11 API, and yes, I got it working. And I'm going to I'm going to share it with you guys over my new project, SLIready.com. As again, www.sliready.com. It's going to be my new project that is going to be free, and it's going to be dedicated to PC gaming, to the computers that are using 2 or more video cards, and the scenarios when NVIDIA driver doesn't support 2 or more video cards in PC games. I'm going to show you how to enable 2 or more video cards in PC game on the same computer and how to double your FPS. And all of this information in form of tutorials, step-by-step tutorials, or even the SLI profile shares will be available over the www.sliready.com, guys. Okay, or iplay4k.com, my main YouTube channel, or iplay16k.com as well. Alright guys, SLI scalability is good, not amazing, but good. At least we are 1.9 times faster than single Titan RTX. But please guys, keep in mind that I'm going to test single Titan RTX as well as two Titan RTXs and SLI in 4K resolution, 5K resolution, 6K resolution, 7K resolution, 8K resolution, hopefully 10K resolution, 12K resolution, and 16K resolution in Battlefield 5, Battlefield 1, Battlefield 4, Battlefield 3, and Battlefield Bad Company 2. So all kind of battlefields will be covered under the two Titan RTXs and SLI guys in all ultra high definition resolutions. In the end of this video, guys, I'm going to share with you my PC hardware specification and provide some more information, as well as I'm going to prove you that I'm not running 4K resolution with DSR right now to make it as 6K resolution. I'm just going to show you my NVIDIA driver and it's going to say there is no DSR right now enabled. But keep in mind that this Apple Pro Display XDR monitor is capable to run 12K resolution, which is 4 times more pixels under the Windows operating system, Windows 10 operating system with NVIDIA drivers. And I'm going to guys show you how to do so in one of my video tutorials, as well as I'm going to show you guys 12K resolution DSR in this Apple 16:9 aspect ratio, which will be a standard, because this 6K resolution by Apple, guys, 16:9 aspect ratio resolution will be standard, because this is the standard by the Apple kind of 6K resolution 16:9 aspect ratio. And I believe that Acer, Dell, HP, Microsoft, LG, Samsung will pick up this idea, and they will use this idea, and they will create 6K resolution 16:9 aspect ratio monitors with the same resolution, 6016 pixels by 3384 pixels in the future. And this is why, guys, I decided to go ahead and show it to you. So it doesn't matter what kind of brand you're running, you will receive the same performance. But of course the monitor is beautiful, but I will never invest $5,000 in 6K resolution monitor, guys, 32-inch, never ever. And plus stand $1,000, so pretty much this monitor costs you with the stand $6,000, and with the additional upgrades $7,000 with a better glass on it. And guys, for $3,000 you can buy old school 8K resolution 75-inch Samsung monitor, or new school in the end of 2020 8K resolution monitors by Samsung or LG for around $4,000. 75-inch will dominate this 32-inch 6K resolution Apple monitor, no matter how beautiful the Apple Retina technology display information looks under the Apple operating system. We are beating it with a Windows 10 12K resolution DSR. It's on another level. When you're watching 12K resolution on 6K resolution screen, guys, it's just on another level. And I'm going to show it to you in another videos over the iPlay4k.com YouTube channel. So don't go ahead and smash that like button, smash that subscribe button, and don't miss it, guys. It's going to be a lot of great videos if you looking to get your PC with this Apple Display XDR screen, or if you're Apple gamer and looking to play some games on Apple Pro Display XDR screen. I will provide a lot of valuable information to you. Keep in mind that 2 Titan RTXs is way faster than 2 AMD Radeon Pro Duo Vega 2 video cards in Crossfire. It's much faster, at least by 2 times almost. Okay, so it's, guys, beautiful visuals, as you can see, beautiful FPS. I show you kind of open world, I show you kind of corridor scenarios, I show you volumetric particles, I show you pretty much everything what you need to see. Okay, now we're going to go ahead and switch to a high preset. Let's go ahead and do that and keep moving. It was morning and now it's day already. I gotta get and do something, guys. So vertical sync is off, high preset, completely high preset, still with the TAA high anti-aliasing. Let's go ahead and have a look, shall we, guys? Beauty. Look at this beauty. As again, the purpose of this video, guys, is not the gameplay. The purpose of this video is not the pixel comparison. Everybody knows 4K resolution versus 6K resolution, there is a big difference. Also 6K resolution versus 8K resolution, there is such a big difference, guys. So there is no Apple Retina display technology will pretty much show you better visual image, no matter what kind of marketers will tell you over the 8K resolution 75-inch. It's just amazing. Okay, but anyways, and it's cheaper too. So to be able, guys, to play this Battlefield 5 on the Apple Macintoshes, Macintosh Pro or Macintosh, you need pretty much the computer that will cost you $20,000. Okay, to be able to play with about 40 FPS, not even 60 FPS that you see right now. Okay, $20,000 computer plus the monitor, around 25. You're looking around $26,000. If you're going to use completely Apple hardware, Apple computer system, and Apple monitor, and Apple operating system. But under the Windows 10 Pro in our case, you can play on a $7,000 computer plus $6,000 into the monitor. So around $12,000–$14,000 almost any games, guys, above 60 FPS average. But you gotta have in that system 2 Titan RTXs, so it's gonna cost you $7,000. So PC experience will cost you $12,000–$14,000. Apple experience with this monitor will cost you around $24,000. Hopefully, guys, this makes sense. Look at my GPU utilization. SLI scalability is good, guys, at least 1.9 times faster. But we're going to find out for sure when I'm going to run, guys, single Titan RTX in Battlefield 5 in 6K resolution. It's going to be a nice test, as well as I'm going to test all kind of different presets, just like I'm doing today. Wow, above, guys, above, I would say 80 FPS average, and the latency delay around 10 milliseconds, 10–12 milliseconds latency delay. When we were running at ultra, our FPS was like 75 FPS average, and latency delay was like 15 milliseconds. But right now is latency delay is below 15 milliseconds, and the FPS is at least 85 FPS average, which is amazing, by the way. I just saw some sort of artifacts. I'm not sure why it was there. I still believe that something wrong with one of my Titans, guys, and I didn't test it one by one yet, but I'm going to test it. When I'm going to test it, I'm also going to repaste the thermal compound paste, and I'm going to use the liquid metal thermal compound paste, and hopefully I'm going to lower my GPU temperatures by 7–10 Celsius. But at least it's going to be by 5 Celsius I'm going to lower the temperature, because liquid metal thermal compound paste is one of the best thermal compound paste in 2020, guys. And yeah, but right now I'm running completely video cards running stock on GPU, stock on a VRAM, and I'm using the NVIDIA thermal paste by default that they came by the manufacturer. So that's why my temperature on the first GPU is 87 Celsius. But keep in mind, it should be 88 Celsius. It should be thermal throttling already by a lot. And I didn't do that because I set 240 millimeter Cooler Master blue fan on top of it, just like on this picture on my wallpaper in the end of this video. This is what I did, and it lowered my temperatures by about 2–3 Celsius, but not that much. And I'm hoping to, after repasting the thermal compound paste, I'm going to lower it by 7 Celsius. This is what I'm looking on average. So pretty much, guys, Titan RTX video card using the Turing GPU architecture by NVIDIA, and that is powering this is our GPU, Turing GPU architecture on our video card that's computing these instructions, and before it's sending into the VRAM, before we see it on our monitor. And when temperature raising above 80 Celsius, we start dropping the megahertz on our GPU frequency, and it's called thermal throttling, and it's lowering the frequency on the GPU, so it's hoping that it's going to lower the temperature as well. So after the 80 Celsius is lowering the frequency. Usually the Titan RTX running 1960 megahertz on maximum turbo boost. So almost 2000 megahertz on each GPU. But just because when you're running in SLI, no matter what you will do, if you're running it on air, it's going to thermal throttle itself, and you're going to pretty much running 1700 megahertz. You're going to lose about 200–250 megahertz at least, and pretty much right now I'm losing about 2–3 FPS. And I cannot overclock my video cards. But if you're going to replace the thermal compound, if you will set it on a hybrid water cooling system by Corsair, let's say, just go ahead and get yourself an extension. And you don't need to do it for 2 video cards. You need to do it only for the first video card closest to the GPU, to the CPU, closest video card to the CPU, because the secondary video card, as you can see, not even going to reach 60 Celsius, so it's not thermal throttling. But just because my frequency today are synchronized, so they're supposed to run same frequencies on the GPU and same frequency on the VRAM, that's why it's lowering automatically on the secondary GPU as well, frequencies. Guys, hopefully this makes sense. Look at this beautiful 85 FPS average. Open world, a lot of things going on here, a lot of volumetric particles right there as a fog, a lot of blowouts on the open world throughout the scene, as you can see, and it's still running beautiful, guys. Wow. And the fire volumetric particles have the collision also physics to it attached, and it's even harder in terms of the FPS than just a regular smoke, which is volumetric particles as well, because fire kind of has to each particles attach the collision thing when it's touching the player, so it's recognizing that. on and off, and it's kind of taxing the GPU performance as well as CPU performance. Look at this beauty, just beauty, guys. The game looks amazing, and even on this 32-inch, even if I'm up to above 60-inch monitors, even on this 32-inch, it looks amazing, and monitor is amazing. But as again, guys, you know, there is no way for me to describe for you how the monitor looks. Go ahead and visit the Apple store and check it out for yourself, but nobody will show you Battlefield 5 running 2 Titan RTXs and SLI on this monitor in 6K resolution. And this is exactly why you're watching my iPlay4K.com YouTube channel. Alright guys, time to switch, and now we're going to go ahead and switch it to a medium now. So we look at the FPS, we look at the utilization of the components. Now we're going to go ahead and switch to a medium preset. Okay, medium preset, and I'm going to turn down the VSync, of course. Let's go ahead and have a look, shall we guys? So this is with the medium preset. Can we hit the 100 FPS average? I'm just curious. And Battlefield 5, guys, even with the medium preset, it still looks amazing. At low, yeah, you're going to start losing some stuff. You will see the pre-rendering level of details and the smaller radius. But medium still looking amazing. And if you're into high FPS, this is probably how you would play it. Medium 6K resolution. But as again, for me, I would play it ultra at 6K resolution, because above 60 FPS is comfortable experience for me. So the status at 6K resolution at ultra preset, guys, was not only playable status, it was comfortable playable status, which is the next level, which is much better. Okay, just want to let you know. Look at this, 90 FPS. We increased by about 5 FPS, 95 FPS average, guys, even 100 FPS. Wow, look at this. And there's the volumetric particles right now going on over here as a fog. And still it's beautiful. A lot of geometry because the building, the players here going on. As again, this is a multiplayer, guys, 64 players playing online. Every single player over here is not the AI, it's a player, real player, playing somewhere in the home on the computer. Look at this, it's just beautiful, and it doesn't matter. All these particles going on, it's still very high FPS. This is unbelievable, guys, experience going on over here. Hopefully, guys, you're enjoying. But below 1800 megahertz per each GPU. So pretty much, if you're going to repaste the thermal compound, pretty much if you're going to keep right now your Titan RTX GPUs at 2000 megahertz stable in SLI, you're going to increase at least by 3 FPS. And just because I'm recording right now with the shadow play, I'm consuming, guys, exactly 3 FPS. So without the recording with the shadow play in real time on the same computer, that taxing 3 FPS, go ahead and add just 3 FPS to the FPS counter. And you will get the FPS without the FPS recording average, without the shadow play recording. Okay, guys? Beautiful, beautiful performance. Looking also beautiful, guys. As again, this is not the gameplay video, it's not about the pixel comparison. Everybody understand. This is just a demonstration, the performance, providing the data, the value to you guys in terms of the information. And 12K resolution hopefully is coming through the DSR on this screen. If not in Battlefield 5, then I'm going to show you some other games, and it will be available over the iPlay4K.com YouTube channel, guys. So you don't want to miss that. Alright, that was beautiful. Let me real quick go ahead and right now switch the preset, and the last preset will be, guys, today at low. Okay, low preset. Here we go. Still anti-aliasing is on, TAA low, because you cannot disable the anti-aliasing in Battlefield 5 game. Keep that in mind. Virtual VSync is off, of course, to show us the maximum possible average FPS. So no matter what kind of hertz of the monitor you're going to have, you can understand what kind of FPS is going to be delivered on that monitor. As again, I'm using 30 hertz today because it's kind of complicated thing in the beginning of 2020 to connect Apple Pro Display XDR screen to a PC, because it's using the Thunderbolt 3 connector, guys, and PCs, my 2 Titan RTXs doesn't have the Thunderbolt 3 connectors. Hopefully in the future NVIDIA will include it, but it doesn't have it. So I used the converter. I purchased the converter for like 89 bucks. It's a BFV converter, and it has the display port on one side, which is 8K 30 hertz, and another side is version 1.4, and another side is Thunderbolt 3. So I'm connecting one cable to my Titan RTX and into that converter, 8K 30 hertz, and then the another cable from that converter from the Thunderbolt 3 to the monitor. okay, and this is the only way it's possible. Hopefully they will release some better converters that will support 8K at 60 Hz, so I can run 6K resolution at 60 Hz. Hopefully guys this makes sense, okay, and it will be available in the future, so it doesn't matter what kind of hertz I'm running right now, but the FPS will be just the same on any type of the hertz monitors. Keep that in mind. Of course there is some, okay guys, so you saw the FPS, the level is over. I'm going to go ahead and shut it down. We are done here. You saw the FPS, you saw everything what you need to see. Check it out. This is during the load scene. The FPS is still above 100 FPS. This is at low. Okay, preset. So I showed you ultra, high, medium, and low. I showed you everything what you need to see. Right now, let me real quick go ahead and show you my computer specification. We're going to talk a little bit. And first of all, let me show you my monitor desktop resolution is 6K, which is 6016 pixels by 3384 pixels, same as our gameplay was. And let me show you the NVIDIA drivers. This is not 4K resolution to DSR to 6K. Let me real quick go ahead and show it to you for those naysayers. So this is my NVIDIA driver, and you can see that DSR factor is off. DSR smoothness is off. And let me show you my Battlefield 5 profile, which by the way I was using the custom profile, and I will share it to you as again over the www.sliradio.com YouTube channel. You don't want to miss it. I'm going to show you how under the Direct3D 11 API to play with 2 or more video cards. And DSR is off, of course. Over here it probably even doesn't show, but it's off. Alright guys, believe me. So if you want to see how beautiful the Apple Pro Display XDR screen looks like, go ahead and visit your Apple store. I mean, I can record a video of 15 minutes of it, but what's the point? I better show you the performance in different games on this monitor that nobody will show it to you. You can see already so many videos on YouTube how the monitor looks like. It's just basically monitor, but the way the way it's showing you the different level of the brightness of that pixel, this is another talk, and you cannot show it on the cameras, guys. Okay, just want to let you know. So let me go ahead and zoom in. I'm going to use the magnifier tool in Windows, and this is the IDA 64 GPU benchmark. When I compare my two Titan RTXs and SLI through that benchmark versus my CPU, which is the only 6 core 6 threads, 5.3 gigahertz, 5300 megahertz per each core. And look at this. This is how it's compared. And by the way, the CPU was running 64-bit native machine code optimized for the CPU. Usually it's 10 times slower than that. It's just heavily optimized code, and the Titans was running the OpenCL. Same algorithms, but different rendering operations. When it was doing that, usually the CPU is about 10 times slower than GPU at least. Okay, and this is my CPU Z, 5300 megahertz per each core, or 5300 multiplier in the BIOS, and I disabled 2 cores in the BIOS, and I disabled the hyper threading technology. So pretty much I avoided to use any virtual cores. I was only using the physical cores, and only 6 of them, and 6 threads, and 2 was disabled in terms of make stable 5.3 gigahertz on each core, or 5300 megahertz. The higher frequency, the better FPS, because the Battlefield 5 guys doesn't need to have 8 threads. 6 threads is still great to go. And this is exactly, but higher frequency will result you in better performance and better FPS. Hopefully we receive, because I overclocked by 300 megahertz extra on each core, hopefully we receive at least 1 or 2 FPS as additional, and it was great. This is exactly what we need to have. Okay, let me real quick, guys, let me show you. The motherboard was the cheapest possible Z390 by ASUS, Maximus 11 here Wi-Fi. I do not advise you to get this board. Get yourself MSI or Gigabyte. This board is horrible, Z390, and Z370 was also horrible. It looks great during the night. I like the LEDs on this board, but everything else in terms of the performance and stability, get yourself MSI board for the same price, or Gigabyte for the same price. You'll receive a much better quality board. Okay, by the way, the DDR4 over here was running 5,000 megahertz by Corsair, the most expensive, over $1,000 16 gigabyte stick. Okay, DDR4 CL18, 5,000 megahertz, guys. But here's the catch: it doesn't work on any Intel boards. Okay, doesn't work Z370, doesn't work Z390, doesn't work X299, Doesn't work on any AMD board, except it works only on one AMD board by MSI X570 Mag Godlike. That is above $500 board, and it only works, this is what the Corsair support team told me, 5000 megahertz CL18. This is what they tested. As again, I have some doubts to believe them that, but let's go ahead and take their word, okay? Because they decided to get and provide me the refund. So in maybe 5 more days, I'm going to be with this memory, and then I'm going to return it. But what I did, it's also on the Z390 motherboard by ASUS Maximus 11 here. It's not stable even at 4000 megahertz. Can you believe it? CL19 even not stable. So the stable frequency, the maximum stable frequency was on this memory 3866 at CL19, and I decided, you know what, I don't like the timing, I don't like that frequency, and I went 2400 megahertz, which is 1200 megahertz times 2, 2400 megahertz on my DDR4 external frequency, and I went CL12. Sometimes I'm switching CL11, but sometimes CL11 is crashing at some games after 20-30 minutes of the gameplay. I'm not sure why. Maybe 11 is not stable. 1T command, so it's very fast, guys, very aggressive timing. And of course, 2 Titan RTX for those haters, 24GB GDR6 Samsung on each Titan RTX. Keep in mind, guys, that Quadra RTX 6000 video card is the same video card, same PCB, same components, same GPU, same VRAM, same components on the PCB as Titan RTX. It's only the NVIDIA decided to go ahead and charge enterprise clients more as double. So Titan RTX already costs $2,500 without the tax. It's very expensive. 2 of them $5,000 plus the tax $5,500. It's a lot of money, okay? Quadra RTX 6000 based on Turing GPU architecture, same video card, same everything, costs almost $5,000, and it will cost you $10,000, and it's for the enterprise clients. And all what I believe, it's just a different BIOS version, but same PCB, same everything. So after a month or 2, I will try to go ahead and flash one of my Titan RTX into the Quadra RTX 6000 BIOSes, and hopefully I'm not going to kill it. But before I'm going to do that, I'm going to record a great videos just in case if I'm going to kill my Titan RTX, okay? And I will try to convert my Titan RTX into Quadra RTX 6000, and it's going to be a nice video experiment over my iPlay4k.com YouTube channel or over the iPlay16k.com YouTube channel that you don't want to mess, okay? And here's why I disabled 2 cores and hyper-threading technology. Let me real quick go ahead and explain it to you. I'm looking at the highest possible single thread performance, because single thread performance times cores will give you the best possible multi-threaded performance as well, okay? And just because 6 cores, 6 threads was more than enough in Battlefield 5 and 99% of the games that I tested in 2019, we don't need to have 8 threads. So that's why I disabled the 2 cores, and I disabled the hyper-threading technology to avoid all these delays, latency delays from the virtual cores, because the controller doesn't like the hyper-threading threads, guys. It's not as fast as physical cores. Hopefully, guys, this makes sense. So let me compare with the different under the version 17.01.64 benchmark CPU Z. Let me compare with the different CPUs. So this is going to be 7th gen Intel, not 9th gen, but 7th gen Extreme CPU that costs way above by 3 times more than my CPU. 18 cores, 36 threads versus my 6 thread CPU, 6 cores, 6 thread CPU. Look at this, not even 3 times faster. And my multi-thread ratio is 5.8, almost perfect. 6 times will be perfect. And he's probably having ratio like 3.7, something like that. And this is just a waste of money, waste of threads, waste of everything, okay? In terms of PC gaming, for sure, and this is not a PC gaming benchmark, this is a multi-threaded benchmark, which is archiving the data throughout the processing pipelines, throughout the threads, throughout everything. So pretty much this is the system RAM CPU benchmark, okay? This is the AMD CPU, which is 32 threads, guys, not even 3 times faster than mine, not even 3 times, and I'm beating by single core performance. So he's probably multi-thread ratio at 3.2 times, which is suck. This is Ryzen 3000 series, guys, 16 threads, not even 2 times faster in terms of multi-threading, 16 threads versus my 6 threads. So you can see how quality this CPU is. So this is the reality. This is not marketing. This is the reality, guys, throughout the PC overclocker, sharing the real true experience and information with you. 22 threads Intel, This is the 9900KF without the GPU on board of the CPU, so without the integrated GPU. Should be faster in terms of overclocking, should conserve less energy, but 16 threads versus my 6 threads, not even 2 times faster. Okay. All right, guys. Right now I'm going to go ahead and scroll it for you. Go ahead and keep your eye, hit pause, and study using this methodology yourself. This is not moot. This is not a misinformation. This is the reality right here. Look at this. 8th generation i7, 3.7 gigahertz stock, 12 threads, 6 core but 12 threads. So additional 6 virtual cores through the hyper-threading technology. Guys, right now I'm not beating it because I'm using CL12 on my DDR4. When I'm using CL11, I'm beating it because my score is on multi-thread ratio. My score is on the multi-thread CPU performance is 3715, 3710. I'm beating it, guys. And this is example when 10 Gen 10600K CPU will be the best Intel CPU in the end of 2020, at least for PC gaming and for the average / advanced users. Okay, especially when you're going to clock at 5.5 gigahertz stable with 6 core 6 threads, it's going to be dominated, guys, like no other. But I'm pretty sure that Intel 10 Gen 10600K Core i5 with 6 core 12 threads will be stable at 5.3 gigahertz. I'm sure about it, guys, with the higher voltage and a beautiful all-in-one system, water cooling system like by Corsair that I'm using today, H150i Pro, triple 120mm fans and one 360mm radiator. It will be stable at 5.3 gigahertz with 12 threads. And imagine 10600K 5.3 gigahertz. For me to match that, I need to be clocked at 5.5, 5.6, unheard of for 9 Gen of Core i CPUs, no matter what CPU you're using in the home safe environment. So pretty much 5.3, I need to be clocked 5.5. So we'll receive additional, at least 5% additional boost, at least, out of this i5 10 Gen. Keep that in mind. Alright, guys, hopefully, guys, I explained to you everything what you need to know today, okay? And real quick, my CPU utilization, you saw it, and this is my IDA64 cache memory benchmark, which is very important. So when I'm running CL12, I'm 50 nanoseconds latency delay. You can beat me with 3600 megahertz probably in terms of read, write, and copy, but in terms of latency delay, and latency delay is very important in PC gaming, in terms of latency delay throughout every single frame is rendered. When you saw that milliseconds, this is nanoseconds, also important factor. So 15 nanoseconds CL12, when this memory is set CL11, almost stable at 90% of the applications, it's 48, 49 nanoseconds. 2 nanoseconds is good to go. At least I received the 100% stable stability. So CL12 is good to go. 2 nanoseconds, not big deal. This is how fast my level 1, level 2, level 3 cache of Core i 9 Gen, 5300 megahertz per each core. In terms of gigabytes data transfer on this core, and in terms of latency delay. Okay? And as again, it says over here that my DDR4 2400 megahertz was CL12, but CL11 is also stable, but kind of not so stable. Okay, hopefully, guys, everything is chicky picky. I explained to you everything what you need to know during this video. Hopefully, guys, you enjoyed my video, and I'm going to go ahead and wrap up with my video. Right now I'm putting some great videos for you to check out. If you don't see it on the screen, go ahead and check out the video description. Please don't forget positive comments, support me with your like, subscribe, share it with your friends, guys. Have a great day, and I will see you till the next time, till the next videos.